All right, guys, we've made it this far. So we're just going to dive right into tackling the audio switch. You guys saw this in the last episode, but let's get straight into it. So the audio switch works off of a resistance ladder, okay? Very quickly going through this. Volume down is 51.1 ohms. Volume up is 51.1 plus 68.1 ohms, or 119.2. And I'll just go through the numbers here. So straight up, skip forward is 210, skip back is 334, and music source is 508. Now, there's something that is resistance called what I call resting resistance, meaning if you don't press any button, the resistance sits at 1,100 ohms, right? What I found is that if you remove the 604 resistor, as long as you're not pressing any bucket, the circuit measures as shorted or completely open, right? And when it's completely open, the resistance is essentially affinity. I've tested this. It works. If you remove the 604 resistor from the S197 switch, it continues to work with no problem. All of the other buttons operate with no issues, and nothing funky or crazy happens. I don't know why Ford opted to do this. I think maybe it has to do with the fact that the voltage needs to go somewhere. But to keep things simple, it actually still works, and I've tried it. So that's important. We'll just remember that later. So when we go through designing our buttons, we need these resistances to be the final resistances that are output by the system, by the new switch. So let's go straight back to the S550 audio control and talk about how this is set up and how it works. Now, this is actually really good. It's a very similar thing. It's a resistance ladder. The problem we have with this is that there's two problems. One, the resistances don't match. And number two, and most importantly, the order of the buttons is different. This means you cannot simply just swap resistors for the right resistances and have them work the same. Okay? What we actually need to do is we need to jump around the buttons, okay, to have it operate the same way. So what I've done is I've designed the schematic, and we'll go up here to audio controls. I've redesigned the schematic so that we can jump around appropriately and actually use the correct resistors to have those, because as you can see, the lowest resistance is volume minus, but on the S550 the lowest resistance is the volume plus. Then the source button, which for us is the highest, for them it's the second, and so on and so forth. So what did I do? I redesigned these various the order, if you will, of these resistances to get it to the appropriate thing. So what we do here is the very first resistor on the S550 is a 35.8 resistor. What we'll do is we'll remove that resistor and we'll replace it with not an SMT or a surface mount resistor, but actually a I don't know what they're called, a bar resistor, if you will, or a wire resistor, and we're going to jump straight from the first thing all the way up to the via, which is the little hole next to the volume minus. That means when you press volume minus, the first thing it's going to get is this 51.1 ohm resistor. Okay, then that will flow through this resistor, and we're going to then jump, adding the 68.1 down to the via near the volume plus. Now this looks a little bit confusing in this diagram, but what we're doing is not only are we replacing the resistors, but we're also rearranging the buttons as they would be pressed as if they were on the S197. Okay, this is what it looks like here. On the actual diagram, this is how you would want to set it up. So what you'll notice is I've removed the resistor number one. I've removed resistor number 2, which is here. I've removed resistor number 3, and this is all done in Photoshop, right? Or I use the GIMP software. Then what we do is we technically won't leave 4, but we'll swap it out for a 124 ohm resistor. Then we'll take off resistor 5 and we'll take off resistor 6. As long as you make these changes, the switch will be compatible and will work. You'll have the 51.1 going to this, these holes, as you'll hear me call them, they're vias. You'll jump to here. Then we go this way to this one. We jump back to here. Okay, that follows this circuit down this way. Then we jump across 90.9 to this via. R4 actually happens to be right where we want it, so we'll just swap that resistor out for a 124. Then we'll go from the via after that all the way up to this via over here, which allows us the next button, and then finally we get a 604 resistor to go to R6. The 604 resistor is actually optional. That's the resting voltage resistor that I kind of proved that we don't need. But if you really wanted to have this a fully continuous circuit board, you would want to add that in. So I have very, very specific instructions here for you guys. This is me doing all my testing. Here are my button voltages that I want. And then with my multimeter, I'm able to test. You can test these from T1. I forget what these are called, but I call them testing pads. You'll be able to test your voltages once you apply all these resistors to make sure you get the appropriate resistance when you press those buttons. Finally, very specifically, what do you need to do? Resistor 1 to 3 and 5 and 6 need to be removed entirely. You won't be replacing them. R4 will be removed and you'll replace it with a 124 ohm resistor, and so on and so forth. The instructions are here. 51.1 ohm resistor goes from the first pad on R1 to the via between R5 and R6. So the first pad on R1 down to the via between R5 and R6. So you follow these instructions very specifically. Now, one of the things that the S550 did is they added these diodes. These diodes actually, I guess they prevent a backflow of voltage. I don't know it that well, but what they do cause is they cause the inability to be able to measure the resistance with a multimeter, because a multimeter, the supply voltage for when you measure resistance is not large enough to open this diode and create continuity. So what I decided to do, again, because the S197 doesn't have it, I just used a wire and I bridge around that diode. So this doesn't look super pretty, but it's functional, right? So I talked about here are my bar resistors. Again, I don't know what they're called. I don't recall, but you can see here I created these traces. I went from the vias to the pads and so on, and this works. It does provide the voltage that I'm looking for, and what I will do is I will attempt to create a video after this, or splice the video into this one that shows that I get the appropriate resistors when I press the resistances when I press the buttons. And that's it for the audio controls. Now, it looks complicated. I'm keeping it on the screen here for you guys if you want. You can pause it. You can get the bands on the resistors I chose. The one thing I will call out is the resistances that are available in the SMD resistors, the surface mount resistors, are not necessarily exactly the same as what's available for the resistors for the bar resistors. Or maybe they are, but they were not available in the big pack I got. So if you'll notice, 51.1, there is a 51 resistor. 68.1, there is a 68 resistor. 90.9, there's a 90 resistor, so it's close enough. The next one up is 124. Well, for me, I found a 120 resistor. And then finally, for the 174, I couldn't find a 174 resistor. I only found a 180. So what I'm hoping is that gets me close enough to the numbers that the system hopefully has a tolerance that will allow it to register those signals. So that is how we'll redesign the audio controls. Again, I'll go back up to this diagram here so you guys can see it, and you can see very specifically where those resistors need to go. So with that being said, guys, that's it, and I will catch you in the next one.